Good evening. Good evening, students. So today I'm going to discuss convex mirrors. Okay. So today's topic is convex mirrors. Drawing the ray diagrams. We'll discuss convex and concave both. We'll discuss. First, we'll discuss concave mirror. Okay. Just we'll learn the rules for drawing the ray diagram. Okay. So this is a concave mirror silhouetted on convex side. The mirror is silhouetted on convex side. It is called concave mirror. So this is the center of curvature. And this is the focus. Okay, now this is the principal axis. So this is the pole of the mirror. This is the pole. This is the focus. This is the center of curvature. Okay. Yes. So now the rules for drawing the ray diagram is before reflection, if the light ray is parallel to the mirror. Before reflection, if the light ray is parallel to the principal axis. If it is initially parallel to principal axis, After reflection, it passes through the focus. So this is before reflection. After reflection, this light ray passes through the focus. Okay. So this is rule number 1. The light ray which is parallel to principal axis, after reflection, that light ray passes through the focus. Okay. And rule number 2 is initially passing through focus. The light ray initially passing through focus, then after reflection, it becomes parallel to principal axis. Class అవుతుంది. After reflection, it becomes parallel to principal axis. Okay, like initially passing through focus, so after reflection, it becomes parallel to principal axis. It becomes parallel to principal axis. Okay, this is rule number 2. Next, suppose passing through center of curvature. So the light ray is passing through center of curvature, then the light ray will retrace the path. So like this, if you take initially passing through center of curvature, after reflection, it passes through center of curvature. It retraces the path. This is rule number 3. The next one is the light ray falling on the pole will be reflected symmetrically. The light ray falling on the pole will be reflected symmetrically. Okay. So like this. This is the fourth. First one is light ray initially parallel to principal axis, after reflection passes through focus. Next one, initially passing through focus, after reflection becomes parallel to principal axis. Initially passing through center of curvature, the light ray will retrace its path. It will come back along the same path. And next, if the light ray is falling at the pole, it is reflected symmetrically. That means this angle, both are equal. Okay. And for different positions of the object, we will find the positions of the image. First, the object is at infinity. If the object is at infinity, suppose this is the principal axis, and this is the mirror. So this is the concave mirror. If the object is at infinity, light rays will be parallel to principal axis. Suppose this is the focus and this is the center of curvature. After reflection, it passes through focus. And you can take one more light ray parallel to principal axis. So if the object is at infinity, if the object is at infinity, then a real image is formed. A real image is formed at the focus. A real image is formed at the focus. It is inverted and highly diminished. The image is real, inverted, and highly diminished. Okay. Next, second one. The concave mirror. Now suppose this is the focus and this is the center of curvature. If the object is in between infinity and center of curvature. Now to trace out the image, take one light ray parallel to principal axis. So this light ray initially parallel to principal axis. After reflection, it passes through focus. Another light ray, take initially passing through focus. So after reflection, it becomes parallel to principal axis. like this. After reflection, initially passing through focus. After reflection becomes parallel to principal. So these two light rays are intersecting at this point. So we'll get a real image in between center of curvature and focus. So this is the object, AB is the object, and A dash, B dash is the image. So if the object is between infinity and C, infinity and center of curvature, a real, inverted, and diminished. Real, inverted and diminished image is formed between C and F, center of curvature and focus. AB is the object, A dash, B dash is the image. Okay. Next, if the object is at the center of curvature. Third case, object at center of curvature. So for that, so this is the concave mirror, this is the principal axis, this is the focus of the mirror, this is the center of curvature. Now object is exactly at the center of curvature. Suppose this is focus and this is center of curvature. Now I am taking the object exactly at the center of curvature. Okay. So the object is exactly at center of curvature. I will draw the ray diagram. First take one light ray parallel to principal axis. After reflection, this light ray passes through focus. Any light ray initially parallel to principal axis that must pass through the focus. Okay. Next, another light ray. You can take passing through focus, or this time you can take like this. Falling symmetrical at the pole. After reflection, it is reflected symmetrically. Okay, like this. So this is initially falling at the pole. It is reflected symmetrically. Able to see here. Now, These two light rays are intersecting at this point. This is the point of intersection. So a real inverted image is formed exactly at the center of curvature. Okay. So if this height of the object is h, height of the image is also h. So AB is the object and the A dash B dash is the image. Like this you can take. First one light ray passing parallel to principal axis. After reflection it passes through focus. Another light ray initially falling on the pole. It is reflected symmetrically if these two angles are equal. So these two light rays are intersecting here. So if object is at C, image is formed at C. The image is real. The image is real, inverted. Image is real, inverted, and of same size. Okay, and of same size. So if the object is at the center of curvature, this is the ray diagram. So like this, you have to draw the ray diagrams to trace out the image. Object is at infinity initially. Image is formed at the focus. For point object, the image is point size image. Even for magnitude of definite size also, image is very diminished, highly diminished. And now, so object is between center of curvature and focus. The fourth case is object is between center of curvature and focus. This is object is at center of curvature. Image is also formed at center of curvature. The image is real, inverted, and of same size. And here, the second one, actually object is between infinity and center of curvature. This object between infinity and C. Infinity and center of curvature. Image is formed between focus and center of curvature. As the object moves from infinity to center of curvature, image also moves from focus to center of curvature. And the next one, object is between, fourth one is okay, object is between C and F. Object is between C and F, center of curvature and focus. If the object is between C and F, then how to trace out the image? This is the principal axis and this is the concave mirror. Okay. Like this. So this is the pole of the mirror. This is the focus. This is the center of curvature. Now the object is between center of curvature and focus. Now drawing the ray diagram. First take one light ray parallel to principal axis. After reflection, it passes through focus like this. So initially parallel to principal axis, after reflection passing through focus. Another light ray falling at the pole. So it is reflected symmetrically. Like this. So these two are intersecting at this point. This is the point of intersection. Okay. So a real image is formed here. Beyond the center of curvature or between infinity and center of curvature. Like this. So if AB is the object, AB is the object and A dash B dash is the image. So here clearly you can observe. So image is formed at if the object is between center of curvature and focus. Image is formed between infinity and C. Image is formed between infinity and center of curvature. Okay. Image is formed between infinity and center of curvature, and the image is real, inverted, and magnified. Image is real, inverted, and magnified. Okay. So if object is at center of curvature, object is at focus, then image will be formed at infinity. Just one more case we will discuss. Object is between focus and pole, F and P. Okay, we'll discuss this case. So this is the principal axis. So this is the center of curvature. So this is the pole, and this is the focus. This is the center of curvature. Now object is between pole and focus, like this. Now for drawing the ray diagram, take one light ray again parallel to principal axis. After reflection, it passes through focus. Okay. Next, another light ray. falling at the pole, reflected symmetrically. Okay. So if you observe, these two light rays are not really intersecting. So then extend them backwards. Extend them in the backward direction. They will intersect some other point. This is like this. This is like this, and principal axis is this. So these two are intersecting at this point. So we will get virtual erect image. So the image is virtual and erect and magnified. Okay. So like this you will get. So if AB is the object, A dash B dash is the image. One light ray initially parallel to principal axis after reflection passing through focus. Another light ray falling on the pole after reflection reflected symmetrical. These two light rays are not really intersecting. So if you extend them backwards, they are intersecting. So A dash B dash is a virtual image. So image is virtual, comma, erect and magnified. Okay. Like this, you can trace out the images for different positions of the object. You can find the position of the image. Okay. Yeah, for taking Unacademy Plus subscription, you can use the code KVSSLIVE. If you take the subscription, you can attend the regular plus classes. So in the next class, I will discuss the mirror formula, magnification formula, and few problems on it. Okay, so yeah, thank you.